Okay, we're going to do vector product, and we've done a vector product already, but there is a second one we're going to do. The first one we did was called the dot product. Okay, this is a way to multiply two vectors together, and if you recall, this was how you did it. This is one way to do it. There was a quicker way also if you had your vectors in I, J, K notation. So the dot product, you take the magnitude of one vector times the magnitude of the other, and you times it by the cosine of the angle. And of course that tells you easily if they're perpendicular, because cosine of 90 degrees is 0. That was one of the useful things there. And when you do that, you get a scalar. It's just a number. Okay, you don't get another vector. But the one we're doing today is the cross product, and this one will give us a vector. Okay, and we write cross products with a cross, and it's also the magnitude of A times the magnitude of B. It's sine instead of cosine, and one last thing is this n hat vector, which, if you recall, the hat means it's a unit vector, so this is a unit vector perpendicular to both A and B. Okay, so let's just draw. So this was in 3 dimensions, by the way. It has to be in 3 dimensions. So let's imagine this is a flat sheet of paper, and both of our A and B vectors are flat on this paper. Okay, here's A, here's B. They're flat on this paper. We've got an angle between them, and so a vector that's perpendicular to both of those has to come out of the page, and there's 2 possible ways it could do that. It could either come up out of the page vertically, or it could go down into the page. Okay, so it's one or the other. And the way you determine which way it is by the right-hand rule. Right-hand rule. Okay, so this is, let me try to draw, I should have practiced this. Little hand here. Some fingers wrapping around. Yeah, that's good. Thumb sticking up. Okay, that's the important thing. Oh, damn, that's a left hand. Let's do that backwards. It's going to be a right hand, because it's the right hand rule. Alright. Here we go. Right hand rule, that's supposed to be a thumb there. Alright. So if you imagine you wrap your right hand around this thing that's sticking up out of the page, or down into the page. Imagine that's a stick and you wrap your hand around it. You can wrap your hand around it one of 2 directions. Either with your thumb pointing up, or you can turn your hand upside down and wrap your hand around it with your thumb pointing down. And the way you choose is you make sure that your other fingers curl around that hand from A to B, from whatever's first, from your first vector, which is in this case is A is our first vector, B is our second vector, just because I wrote them in that order. I could have written B times A. So it has to go from A to B in the shortest direction. Okay, so, oh, damn it, what happened? Okay, so you wouldn't go from A to B this way. That's the long way. Okay, we don't do that. So if you wrap your hand so that your fingers are pointing, and you're starting at A and then they're wrapping around to B, we'll go over this in class, but you'll find that you end up with your thumb pointing down. Okay, so that is that tells you the direction. So for an example, let's just do an example here. EG1. let's do it again. We'll draw a page. We'll draw a couple of vectors. Let's say this one is P, and this has a magnitude of 5. This is Q. It has a magnitude of 8, and we've got an angle of 30 degrees between them. Okay, they're both flat on this page. P times Q is magnitude of P, magnitude of Q, sine of the angle between them, and times this normal vector. Okay, so in this case it's going to be 5 is the magnitude of P times 8 is the magnitude of Q, sine of 30, I hope that's 0.5, I think it is. Okay, and times whatever this normal unit vector is. Of course, the magnitude of a unit vector, well, it's a unit, that means 1, so that's not going to change the magnitude of the whole thing. We're going to add this in here anyway. So basically 5 times 8, 40, times 0.5 is 20, so it's basically telling us 20. And if we use that right hand rule from P to Q, wrap our hand around it, our thumb is going to be going in a downward direction. Okay, so this means that P times Q is going to be going this way, and the magnitude of P and Q, P times Q, I can do magnitude like that, is going to be 20. Okay, so it's a vector going down. And if I reversed the P and the Q, if I did Q times P, since Q comes first, nothing else is going to change except that when I wrap my finger from Q to P, my thumb is going to point up. So this is going to be 20 in an upward direction. Again, so magnitude of 20, so this is Q times P. Okay, so that's one way to do it. Now, when you have I, J, and K, it's just like with dot product, we've got a slightly simpler formula we can use, which I won't go into how we got it right now, but let me just do this example. So if A equals, let's say 2I minus J plus 3K, B equals 3I 2J minus 5K. Okay, the way you can calculate the cross product is a nice simple method, and it is using a determinant of a 3x3 matrix. Okay, it's kind of weird, but this is what we do. Okay, the first row, IJK, always IJK. Second row, I'm using the coefficients from A. I'm using my 2, because I've got 2I. I'm using minus 1 because that's how many J's I have, and I'm using 3 because that's how many K's I have. Okay, so that's my first, that's my A. Then I go to my B, how many I's? I've got 3 I's. How many J's? 2. How many K's? Minus 5. Okay, this is a determinant, so I'm going to put these vertical lines. That's how you write determinant. And so now to work out determinant, if you're using the formula way to do it, it's I times the determinant of everything that's, you cross out the top row and the left row, and you've got minus 1, 3, 2, and minus 5. That's the determinant. The J becomes a minus, the determinant of everything that's left there, which is the 2, the 3, 3 minus 5. Just that is after crossing out the J column and row, I'm left with 2, 3, and 3 minus 5. Just a reminder how I got that. And the last one is K times the determinant of 2, minus 1, 3, and 2. Okay, so that first determinant, I've got a minus 1 times a minus 5, so that's a plus 5, minus 3 times 2, plus 5 minus 6 is minus 1. So that means minus 1i, or just minus I. Okay, next one. 2 times minus 5 is minus 10, minus 3 times 3 is minus 19, and it's minus 19 times minus j, so that makes it a plus. Plus 19j. Last one. 2 times 2 is 4, minus a negative 3 is 7, that's a plus 7k. So that's it. Done. That is my cross product. So let me just give you one to do for homework to bring to class. So let's say we've got P is 3i plus 7j minus k. Q equals negative 5i minus j plus 6k. Okay, so work out 1p times q, and also work out q times p, and we'll go over that in class tomorrow. Okay, see you then.